Let me share my screen. Excellent. So, as we discussed, I believe 2 weeks ago, um, you wanted me to look a little bit deeper into the various statistics, if you will, of from above canopy and below canopy or at canopy levels. Um, when it comes to CO2 flux, H2O, air temperature, um, and so really what I did was I downloaded the data from the Google Drive and I compared and contrasted each of the canopy levels and I overlapped them onto various graphs, which I'm going to show next so that we could understand what their trends are. And what we somewhat see is, at least for the CO2 flux, for example, one could compare it to an inverse function. So to an extent, really it's like you flipped it over the x is equal to, excuse me, the y is equal to zero axis. And so I would say it's very similar to that um, for the above versus below canopy for the CO2 flux. Oh, and then for the H2O flux, and I was a little bit curious about this. So the canopy, the H2O doesn't seem to vary very much, but the above canopy does. Why would that be? Is it due to like precipitation, or I was a little curious about that, Dr. Wang.
Uh, this is yeah, because of the below canopy, the transport, the turbulence is weak, so the transport is weak, it's lower.
I see.
So there's a little vapor transport below canopy because the wind is calm. Uh, but above canopy, there's a free exchange between canopy and the air.
I see.
Below is very surprised.
I see. Okay,
That's the reason, I
that makes
think.
sense. And then moving forward with the heat flux, as you can see, it's very similar to the data we witnessed with the H2O flux. With the heat flux, you have much more variation, though it doesn't go too negative. It definitely has much higher peaks compared to the canopy. Although
Mm-hmm.
one could argue that there is an outlier around this area of the graph.
Mm-hmm.
And so moving forward, this was, I believe, probably one of the more interesting and definitely visible relations, if you will. Whether or not it's a correlation, that seems a little inconclusive at this point, but they do seem to follow very well
Mm-hmm.
when it comes to the above canopy and the canopy for the temperature. So there's definitely a relationship there in how they trend.
Mm-hmm.
And so those were the observations, as we stated before. But just as an overview, the CO2 fluxes, we noticed that it was basically for the above canopy. You can imagine it as a positive value, if you will, like it was above the y is equal to zero line. But then with the canopy data, it essentially flipped over that line, and you could kind of say it was like an inverse to a certain extent. Not really sure if you necessarily say that, but you could. In addition to that, okay, and in addition to that, what we see with the above canopy for the heat is that it definitely has a greater magnitude than for the canopy heat, and very, also similar for the above canopy, has a greater magnitude overall. In that, when I mean magnitude, I should be a little bit more specific there. I should mean that there are much higher peaks. There's clearly more variation compared to the at canopy level. So you can really see there, if you were to do an LSRL for comparing the above canopy and the canopy, you would really see that there's little. I would believe you would see little relationship between them. You'd probably have a rather low R value compared to the at canopy level. And then for the air temperature, as I stated before, I believe this was I thought this was rather interesting, um, and pivotal to a certain extent because the other data we witnessed, the uh, the lines didn't trend very much. There were some trends. One could argue that, but it was not very significant. But I truly believe this is significant. And when I mean significant, I don't necessarily mean statistically significant. I just believe that they are very important to observe and understand. And so, what I want to do next, uh, moving forward, is definitely look into the 1 hertz and 10 hertz data and compare both of them at different time intervals and to see how they trend and whether or not they trend similar to what we've seen with the air temperature, or if we're going to see more variation in the data as we've seen uh, in some of my previous presentations, such as with the March and December data, though it is rather plausible that those pieces of data were outliers. But yes. Do you have any questions, Dr. Wang?
No, it's good observation.
Okay, thank you.
Yeah, this is interesting. You notice the air temperature difference is consistent, but below is below canopy temperature, air temperature is lower than above. Do you remember what you show in the poster or somewhere of air temperature below and above?
Wait.
Yeah. A different height. I don't remember seeing that below canopy.
You mean the temperature at different height, right?
Right. You have below and above canopy top because temperature.
We have temperature measurement at several heights.
So is the above canopy has higher?
I remember just the temperature near the surface.
Air temperature.
Yeah, I know the air temperature. I remember for the air temperature near the surface, near the soil surface, is always higher than others. Except that all of the air temperatures are pretty similar, I remember. For air temperature, I mean. I can share that if you want.
Let's take a closer look.
Yeah, have a quick look, please. You see, this is the blue line. This is the plot for the